Thank you, Chair Duckworth. Thank you so much again for chairing this important hearing and for all our witnesses and describing the advancements in aviation that may not be all here, some are here, but what we need to continue to work on for U.S. competitiveness. Mr. Pierce, I'd like to start with you. I'm very interested in the high-rate composite aircraft manufacturing program, HICAM. This is something that I certainly believe we need to do. There are multiple companies like Boeing and Mukilteo-based tooling company Electro Impact are involved in HICAM. Obviously, the CHIPS and Science Bill said let's continue to make sure that we're on the cutting edge of aerospace manufacturing and scaling up on the certification process. NASA has clearly recognized how important this is to invest in composite manufacturing. What do you see as the latest, the largest impediments for us moving forward? What else do you think we need to do to really be successful here in the next phase of manufacturing?
Yeah, the challenges that we're going after with respect to HICAM is really the ability to produce composite aircraft structures at rate. Today, it is a state-of-the-art in terms of aircraft production, especially if you look at the Boeing 787, the Airbus A350. They are composite aircraft, but they can only be produced economically at relatively low rates.
So you're saying 10 to 14 a month?
Right, and if you want to do that for a single-aisle aircraft, you'd have to get that up to 60, 70, 80 aircraft a month. And the way current composites are produced doesn't allow you to do that economically. You'd have to essentially create lots of parallel lines, which really would just not be affordable. So what we're doing is looking at the composite material systems and the ability to produce those at much faster rates. And so we've got, in fact, today, or just a little while ago, we through our Advanced Composites Consortium, which has been together now for, probably close to 10 years now, that brings together the U.S. composite manufacturing industry. We've just had let several contracts, about 30 contracts, to look at the fundamentals of the different material systems and what it would take to speed those up. And then based on the results of those studies, we'll take the highest leverage components of that and then take those to higher scale so that we actually get to demonstrate at near full scale the ability to produce these composite aircraft at higher rates. So that's the focus we have.
Are we falling behind here?
Well, I'd like to think that, through our previous effort, the Advanced Composites Project, which demonstrated that we can speed up the rate at which we develop and certify these aircraft, and now with what we're doing to speed up the manufacture, that we will stay at the leading edge of composite aircraft development and manufacturing. But if we don't do these things, yes, we will fall behind.
Well, I think, obviously, for people who may not, composites or lighter weight materials drive down on the fuel costs. That's correct. Clear, but I have a lot of aerospace machinists in my state. I'm pretty sure Senator Cruz has a lot of aerospace machinists. They want to be on the cutting edge of technology. They want to be driving. I know that there is a thermoplastics center, I think it's in the Netherlands, that people are working on. So I think our people want to know what we're going to do to be aggressive here, both with the public and private sector. So something, I think when we saw CHIPS and Science as an opportunity to make sure we were doing that.
And thermoplastics is one of those areas that one of the material systems we're focused on. We're trying to be very objective about which material systems will provide the best performance with respect to the application that's being desired. So we're kind of trying to keep that aperture open.
You, in your testimony, mentioned, I think you called it GRX10, new composite materials.
It's actually a metallic alloy system used for a very high temperature. For example, in turbine engines, where you're exposing these materials to very high temperatures, this GRX-A10 could be a good innovation in that space.
So we just need to get a big banner that says material science is key for aviation's future.
It is critical.
I see everybody nodding.
It is critical.
Everybody's. Well, I don't know that we've said it so specifically, and we need to, because the material science aspect of this really important, and obviously then the minerals and everything else. Mr. Hedgeman, Dave Calhoun, CEO of Boeing, has said a new U.S. major aircraft program will not be announced until 2030, and that we wouldn't expect a U.S. commercial airliner to be new one built in service until 2035 at the earliest. I think part of what they're waiting for is what they think is clarity and leaps in energy engine technology. Do you agree with that time frame?
Yeah, we're working very hard on maturing our technologies and demonstrating that they're safe and durable for engine programs that can move into a certification type effort. So for the next couple of years, this decade, we have a series of demonstrators that do exactly that. Once that is completed and you have shown that indeed these technologies are delivering and are safe, at that point you kick off the design effort and the certification effort towards those new applications, which then would fall sometime in the 2030s.
What is going to be the additive advantage? How would you describe it?
What
do you think is the engineering efficiency that you're going to get out of the next engine?
The fuel efficiency that we're going after is more than 20%, which is significantly more than what you traditionally get in a generational update.
And you're going to do that, again, by these material science issues, or?
A lot of it is material sciences. We have, in our LEAP engines, we've introduced new materials, ceramic matrix composites that are more temperature resistant than any metal. They are lighter, they're stronger. That path is continuing in our technology growth, which gives you thermal efficiency inside the engine. It's a very large part of what the next generation engines will continue to improve on. The other large part is the propulsive efficiency, which is our open fan architecture.
Thank you. Thank you, Madam Chair. I will definitely have more questions, but yield to my colleagues.
Thank you, Chairwoman Cantwell, and I recognize